All right, let's jump right into this. Welcome to today's explainer. We are tackling something that's absolutely crucial if you're writing Java, type conversion. Look, if you've ever been coding and suddenly hit with that dreaded incompatible types error, yeah, you know exactly why we're talking about this. Today, we're figuring out how to manage our data seamlessly without crashing the whole application or, honestly worse, silently losing data. Think of data types as boxes of different sizes. Today, we're learning the actual physics of moving stuff between those boxes. So here is our roadmap for today. Number 1, we're demystifying type conversion. Number 2, implicit versus explicit casting. Number 3, the dangers of narrowing. And finally, number 4, type promotion in math. Let's kick things off with section 1, demystifying type conversion. Imagine you're packing for a trip, right? What actually happens when you try to cram a massive, puffy winter coat into a tiny little shoebox? Well, it just doesn't work. You either need a way bigger box or you have to, chop up the code, which obviously ruins it. Java handles memory pretty much exactly the same way. Every single variable you declare, whether it's an integer, a float, a byte, it's essentially a container built to a very specific size. And when you try forcing mismatched data into those memory spaces, well, Java is forced to make a decision about what to do. Which brings us right to our core definition, type conversion or typecasting. This is literally just the process of converting a value from one data type into another data type. It's your ultimate tool as a developer to solve that whole mismatched box problem. The catch? Sometimes Java takes care of this for you automatically, and other times you have to grab the steering wheel and do it yourself. Let's get into section 2, implicit versus explicit casting. This really highlights the main difference. On the one side, we've got implicit casting. This is completely automatic. It happens when you move data from a smaller container into a larger one. It's kind of like pouring a tiny cup of water into a giant bucket. Super safe, zero spills, and Java just handles it. But on the other side, we have explicit casting. This one is entirely manual. This is what happens when you try forcing the contents of that giant bucket into the tiny cup. Java flat out refuses to do this automatically because, well, data is going to spill everywhere. You have to manually step in and authorize it. Let's actually look at implicit casting in action. Check this out. We have an integer, num, set to 4. Then, right below it, we create a long variable named L, and we just assign num directly to it. Notice how crazy simple that is. An integer is a pretty small box, and a long is a massive one. So the Java compiler looks at this and goes, yep, no problem at all. It seamlessly converts the smaller int into the larger long. You literally don't have to write any extra code. Now, flip that around and look at explicit casting. We've got a floating point number, flow, set to 4.5. A float holds decimals, which makes it a more complex or larger data type when it comes to precision. If you try stuffing that into an int, which only deals with whole numbers, Java kind of freaks out. To make this actually work, you, the programmer, have to step in. You see that int wrapped in parentheses? That is your explicit cast. You are telling Java, look, I know what I'm doing, force this float to be an integer. Moving right along to section 3, the dangers of narrowing. When you start manually forcing data into those smaller containers, things can get really messy. Take this floating point number from our source material, 5.6. Imagine this is a vital piece of data in your app. Maybe it's a critical financial calculation or a coordinate for a physics engine. It's not 5, and it's not 6. It is exactly 5.6. But check out what happens if you explicitly cast that float down to an integer. Boom, it's just 5. The narrowing conversion literally chops the decimal right off. You experience an exact loss of 0.6 in precision. And think about that. In a banking app, losing decimals literally means losing money. In a video game, maybe your character completely misses a jump. When you force a large data type into a small one, you are actively agreeing to lose data. Because losing data is such a massive risk, Java acts like a strict parent here. If you try a narrowing conversion without that explicit casting syntax we just talked about, you hit an absolute wall of errors. The compiler stops you dead in your tracks with possible lossy conversion warnings. Whether you're shoving a long into a byte, a double into an int, or a float into a short, Java strictly enforces the rules. It flat out refuses to compile until you explicitly confirm, yes, I accept the risk of losing this precision. So it's strict on the way down, but incredibly helpful on the way up. Which brings us to our final part, section 4, type promotion in math. Just take a look at the pattern in these operations. When you do math with two different data types, Java isn't just randomly guessing the output type.
It follows this really brilliant rule called type promotion. It automatically upgrades the smaller data type to the larger one involved to prevent you from losing anything. So if you divide an int by a float, the whole result becomes a float to keep those decimals intact. Multiply a short by a long, the result is automatically promoted to a long.
Here's a great little anecdote from the source material to really hammer this home. We have two bytes here, B and C, and they're both set to 120. Now 120 fits perfectly fine inside a byte because a byte maxes out at 127. But what happens when you multiply them together? 120 times 120 is 14,400. That completely shatters the 127 limit. If Java tried to keep that result as a byte, your app would just overflow and crash. But thanks to type promotion, Java looks ahead, realizes the math is way too big for a byte, and smartly promotes the result up to an integer. It completely saves you from a silent mathematical disaster.
Okay, so we've covered how implicit casting keeps your data safe, how explicit casting requires you to be really deliberate, and how type promotion is basically your built-in safety net. So I'll leave you with this one final question. Now that you know exactly how Java promotes and casts types under the hood, are you actually double-checking the math in your own code to prevent silent data loss? Seriously, next time you open up a project, take a hard look at those explicitly cast variables. Make sure you aren't accidentally chopping off the exact precision your app needs to function. Keep learning, keep coding, and I'll catch you in the next explainer.